In earthquake science, more so than many other fields, we are very interdisciplinary. We look at the system. The system is rocks and fluids that is deformed by forces that act on it, the plate tectonics, or the loads from the atmosphere or the rain. So we have these ground-based sensors that records the motions that are generated by the seismic waves from an earthquake. And given the information on when the waves arrive, we track where the earthquake is. So if we have many sensors, many earthquakes, we can create very accurate or very detailed cloud points of where the earthquake sequence originates from. And from there, we can try to understand the different fault configurations. So this is a very dynamic system. There's this multimodal in dimension, there is multimodal in type of data that we would like to use. So that's where interdisciplinary science is the ability to fuse all of these data and make sense of it.
When I came to the lab in 2021, the first thing I do is pulling the data from the National Data Center. And it took me 4 months, literally 4 months, to pull in 100 terabytes of data because we're not on the cloud. Now we're working on 1.3 petabytes of data. And the cloud platform is able to provide such scalabilities that tasks used to spend months can be finished within days or hours. That saves money, saves time, and potentially accelerate how we can get to the result.
Our domain is actually expanding beyond the pure earthquake tectonic science. We're moving much broader. We are intersecting with other fields that have actually usually different data sets. So what we can do with that data that is beyond earthquakes, and we started experimenting on that, is we can detect anything that generates vibrations. HVAC, a car, a tree swinging, a whale singing, glaciers when they slide, they stick and slide, stick and slide. And if it shakes the ground, we see that on the sensors. Before the rise of what we call array analysis, network analysis, these individual observations were difficult to attribute to a given phenomena. But because now we can say, hey, the sensor nearby sees the same thing, maybe I have a third sensor, I can start locating the events. And now we can say that's a real event. And so we are learning a lot more about the Earth system because we have more sensors that can cross-validate the observation. They give us different perspectives. And from there, we can actually do more about environmental monitoring, urban traffic monitoring. And what's going to be great with the cloud infrastructure that supports this analysis is cloud is very suited for multimodal data, time series, images, text. It's something that can be easily integrated together to look at a system because the architecture of the storage is so flexible. This is the right infrastructure for us doing interdisciplinary work where we can actually merge and fuse these different data modalities. So, all together.